All right, so this next question is about electrostatics. Okay, it's a 3-marker to explain how these squares of material stick together, and we need to use ideas about electrostatic charge in our answer, right? Okay, so the first thing is, if they're sticking together, okay, then they've clearly got opposite charges, right? Okay, so just for saying that they've got opposite charges, okay, and the opposite charges attract, okay, then already, we're addressing this thing, right? But it's important that we say that they're attracting to each other rather than sticking together to show that we've really understood what's going on there, right? Okay, now how could you get opposite charges? Well, the first way is that you could knock some electrons off one of these squares. Okay, and if you did that, you'd leave behind a net positive charge. Okay, how can you knock electrons off something? Through the process of friction. Okay, so if you think about pretty much the whole of electrostatics, okay, 99% of electrostatics works through the process of friction, okay, which is knocking off these electrons off that material. But if we need oppositely charged materials, then yes, some of the things must be getting positively charged by losing electrons. So how could we end up with something that was negatively charged? Well, we'd have to add in an electron. And if you add an electron to a neutrally charged material, then that's going to become negatively charged. Okay. And again, that's through the process of friction. Okay. There we go. That's enough for 3 marks there. Okay. This idea of friction, the idea of opposite charges attracting, and then some detail about how we can create those opposite charges. And that was all we needed for question 8.